Okay, so today we're going to learn 6.1 quantity represented by the gradient of a graph. Okay, so we learn step by step. So the first thing we learn is stating the quantity represented by the gradient of a graph. Okay, so we learn the concept first. Okay, so the gradient of a graph is the rate of change of the quantity on the vertical axis with respect to the quantity on the horizontal axis. So the meaning of this whole sentence is rate of change, which is a gradient, okay, is vertical axis divided by horizontal axis. Okay, so look at this. Okay, this is the graph where you have the volume of water used and time. So the gradient should be change in volume of water used. Okay, why is it change? Because through the time, the volume of water increases. So this is a change. Okay, this is a change. And then change in time, months. Okay, so the rate of change is actually rate of water usage. Okay, meter cube per month. Okay, next. This one. This is distance over time. Okay, so the gradient should be change in distance over change in time. So distance over time should be speed. Okay, your speed, kilometer per hours. After that, this one is speed over time. Okay, so the gradient is change in speed, change in time, over change in time. So it should be acceleration, meter per square second. Okay, so we need to draw. Okay, learn how to draw a distance time graph. So a school bus departs from a school and its distances in the first 6 minutes are tabulated in the table below. Okay, so the table is this. Okay, so you see from the 0 minute until the 6 minute, okay, the bus actually traveled for 4,500 meters. So we need to use a scale of 2 cm to 1 minute on the x-axis and 2 cm to 500 meter on the y-axis. Draw a distance time graph. Okay. So the graph should looks like this. Okay. So distance should be 2 cm to 500 meters. So we go all the way like this. Minute should be 2 cm to 1 minute. Okay, so your graph should be a straight line. It always be a straight line, okay? So 6.1c, we'll be learning finding and interpreting the gradient of a distance time graph. Okay, so gradient of a straight line, okay, is like this. So we only use y2 minus y1 over x2 minus x1. Okay, even though reference book has two methods, okay, this method is easier to remember. Okay, y2 minus y1 over x2 minus x1. Okay, so look at this. The distance time graph shows the journey of an express bus along a highway from a point 20 kilometers from the bus station. Okay, so this is your distance time graph. So calculate the gradient of the graph and interpret the meaning of the gradient of the graph. Okay, so we calculate the gradient first. Okay, so the gradient of the graph, I take the highest one, 100 minus the lowest one, 20. And for time, I take the longest one, 60, minus the shortest one, 0. Okay, 100 minus 20, I'll get 80, but normally speed will be kilometer per hour. So 60 minutes, you have to divide another 60 to get hour. Okay, so 80 kilometer divide by hour, 1 hour. So we get 80 kilometer per hour. So this is the gradient of the graph. So the gradient of the graph represents the speed of the express bus. Hence, the speed of the express bus is 80 km per hour. So 6.1d, we need to calculate the speed from the distance time graph. So speed is always the gradient, okay, the rate of change. So let's look at this. At 7 a.m., a lorry is at 20 kilometers from town P. It is heading towards town Q. After reaching town Q, it travels back to town P. The distance time graph shows the whole journey of the lorry. Calculate the speed in kilometer per hour of the lorry for the journey from 7 a.m. to 9 a.m., 9 a.m. to 10 a.m., 10 a.m. to 12:30 p.m. So speed from 7 a.m. to 9 a.m. should be, the highest is 120, lowest is 20. Okay, and it goes for 2 hours. Okay, so 100, okay, divided by 2, get 50. And then speed from 9 a.m. to 10 a.m., it's, the later one is 120 minus 120, okay, and it only goes for 1 hour. So 0 divided by 1, so still 0 kilometer per hour. Okay, and then after that, speed from 10 to 12:30. Okay, so this one, the later one is 0. Okay, minus the initial is 120. Okay, later minus initial. Okay, and then after that, divide by 2 hours and a half. So negative 120 kilometer divided by 2 hours and a half. Then it's negative 48. Okay, so actually this means that this person, okay, this lorry traveled to town Q, and then it rests at town Q for 1 hour, and after it come back to town P. Okay, so we need to draw the graph of the relation between two variables and stating the meaning of its gradient. So you see, the number of words typed by a typesetter, okay, and in the period of t minutes is given by the relation n equals to 30t. So we need to complete and copy and complete the following table. So I have completed on behalf of you guys. Okay, so using a scale of 2 cm to 1 minute on the x-axis and 2 cm to 30 words on the y-axis, draw the graph of n against t for 0, okay, less than equal to t, less than equal to 6. Okay, so this is my graph. So we need to state the quantity represented by the gradient and calculate its value. So I take the highest one, the later one is 180, the initial is 0. Minutes will be 6. Okay, so I'll be using this way. So 180 Newton and 180 N divided by 6, you get 30 number of words per minute. Okay, so further example of distance time graph, okay, is this one. So the diagram shows a distance time graph of the whole journey of Puan Zoraida from her house to the hypermarket and back to her house. Okay, so we need to calculate the period of time in minutes during which Puan Zoraida is at rest. Rest should be this. Okay, so it's 15 to minus 9. So it is 6 minutes. Calculate the speed of Puan Zoraida in the first 9 minutes. Okay, when you want to look speed from distance time graph, you need to find gradient. So I just use 5670 divided by 9 minutes, and then I will get 630 meter per minute. If the average speed in the first 32 minutes is 312.5 meter per minute, find the value of D. Okay, first 32 minutes. The average speed is here. So we have average speed equals to total distance traveled over total time taken. Okay, so average speed is 312.5 equals to D, okay, divided by 32. So D is equal to 312.5 multiply by 32, you get 10,000. Okay, so the distance at D will be 10,000 meters. Lastly, calculate the average speed of the whole journey of 47 minutes. Okay, so average speed of the whole journey is total distance traveled over total time taken. Okay, you'll be wondering why it's 10,000 plus 10,000 because Pons Loretta actually goes to the supermarket and come back home. So this is a total distance. Okay, so you need to satisfy the whole graph. Okay, divide by 47 minutes. So you get 425. Okay, and then 25 over 47 meter per minute. Okay, so this is the end of the lesson.